Um, hey guys, welcome back. So this is going to be the last video for the lecture video series on the linear histology. So we have looked onto classic lobule. Now in this video we're going to talk about the portal lobule as well as the hepatic acinus. So as for the classic lobule, we have central vein at the center and portal triad at the periphery, and blood is actually coming from the periphery to the center. So the classic lobule model is actually explaining the liver as the endocrine gland, where the liver is actually secreting the plasma protein, active vitamin D, coagulation factor, apoprotein, and so many other things into the blood. That's why you call it. That's why that model explains the liver as the endocrine gland. So as for the portal lobule, so we gonna talk about the liver, which is gonna act as exocrine gland. Okay, why? We will look into that now. So the first point that I want to talk about is, okay, this okay, this model is actually explaining the direction of the flow of the bile. Okay, as you can see here, as I mean, you know the fact that the bile always moves from the central vein to the periphery. So that's why I've drawn the arrows that are from here to here, 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 here to here. So when you actually combine all these vectors, you will actually get this shape like this. Okay, it is always going from the center to the periphery. Okay, so this actually direction is actually showing you that the bile is moving towards the periphery. The second point is that this triangle is actually showing a bile secreting structure moving to the periphery. Okay, this whole thing is actually showing that the bile secreting structures that's moving to the periphery, and this type of lobule is known as the portal lobule. So in this model, that's why as I've mentioned before, this model, the liver is being shown as to act as an endocrine gland, because liver here is actually releasing bile, and bile is not secreted into blood, so they are not endocrine. That's why we are calling it as an exocrine. We are just releasing it directly into the intestines, or yeah, to be precise, is the second part of the duodenum. It's just going to empty itself in the second part of the duodenum, so it's not going to blood. That's why we are calling it as a exocrine gland. So we have looked into how the liver can act as an endocrine gland through classic lobule. We have looked into how the liver actually can act as an exocrine gland through portal lobule. Now let's look at the liver as a metabolically active lobule through the hepatic acinus model. So in this model, okay, so this is, as you know, the portal triad, and this red color is actually showing the direction of the blood flow, which is actually moving from the periphery to the center. So okay, functionally in this model, hepatocytes functionally hepatocytes which are at the periphery has a better blood supply, while hepatocytes which is at the central vein, they are actually poor O2 supply, because blood is actually going to move from this side to this side. So that's why the hepatocytes that is at these areas, zone 1, they actually can get more oxygen than the one that is actually at the center. Okay, the blood moves from the periphery to center. So the first thing that you need to know is hepatocytes on the outer side has well oxygenated blood, this side. Okay, and hepatocyte at the central vein would be having a low oxygen supply. So the hepatocyte actually can be divided into three regions. Zone 1, this one, which is well oxygenated, so hepatocyte would be receiving maximum oxygen. Zone 2, which is mediumly oxygenated, and zone 3, which is poorly oxygenated, this side. Okay, and hepatocytes would be receiving minimum amount of oxygen, and zone 3 is also known as a pericentral hepatocytes. Okay, so in this model, we are actually trying to classify the hepatocytes into three zones according to the oxygen content of the blood as it passes through the sinusoid. So this type of classification is also known as the hepatic acinus model. So complication due to this architecture is, first, if there is severe ischemia to the liver, cells in zone 3 die faster, because okay, let's say let's say in the condition of the congestive heart failure, the heart is pumping very poorly, so the liver is already receiving less blood, and zone 3 hepatocytes undergo severe ischemic injury because they are actually, the heart actually cannot pump blood properly. Already this part, zone 1 itself, it is receiving less amount of oxygen, not to say that zone 3. So that zone 3 will actually undergo severe ischemic injury. So what will happen is the hepatocytes will go to full necrosis or be bloated with fats, because the lipid received cannot be catabolized, and whatever they synthesis also cannot be secreted. And as I have mentioned before, this side of hepatocytes is also known as a pericentral hepatocyte. So when the systemic injury onto this side of the hepatocyte, the zone 3 hepatocyte, they will call that condition is also known as the pericentral necrosis. So the next thing is zone 1 is the hepatocytes which receive maximum amount of nutrients from GIT. Okay, since blood actually comes from this side to this side first. Uh, so more glucose will be taken up by hepatocytes in zone 1 and less by that of zone 3. Okay, that is the second point of not complication, it's just a fact of this architecture. The third one that you need to remember is, if there is chronic inflammation in the liver, inflammatory cells will come to liver parenchyma such as neutrophil and macrophage. So which zone will suffer first? So obviously zone 1, because it is the closest to the hepatic artery. So hepatocytes in zone 1 are exposed to more inflammatory cells. Okay, whereas for toxins, uh, toxins or certain bacteria such as Proteus vulgaris coming to blood, so that will also affect zone 1 first, because zone 1 is the one which is actually being exposed to those blood first. So in summary, that you need to remember is that many toxins and bacteria, inflammatory disease, nutrients and hormones affects zone 1 more, whereas zone 3 is where ischemic necrosis will do maximum damage. And another thing that you need to remember is there are some other toxins taken up by hepatocytes, and to detoxify these toxins, hepatocytes needs a lot of oxygen. And this type of, for example, one type of toxins of this type of is carbon tetrachloride or CCl4. So if someone is exposed to this toxin, damage is done more to zone 3, because zone 3 is like receiving less amount of oxygen. So when there is less amount of oxygen, you cannot detoxify these toxins, and these toxins will do more damage onto that zone. So because detox is based on the oxygen availability. So that's all for this lecture video series on the liver histology. Hope you guys learned something new. So if you guys think that I should add something, just put down there in the comment box, and I'll try to put it in the video through the annotations and all. So that's all guys, thank you.